In this presentation, we're going to look at the binomial distribution, and in particular what we're going to do is look at how we can approximate the binomial distribution with the normal distribution. So it's a quick worked example on that really. So in an opinion poll, each individual in a random sample of 275 individuals from a large population is asked which political party they support. If it's known in general that 45% of the population support party A, calculate approximately the probability that at least 116 people in the sample support party A. Now, here's a bit of a steer there. It sort of says approximate. Okay. So I've done a few of these questions before, so you can look at some other worked examples there. But just actually just a quick remark on the continuity correction table there. So this is just something to just get right. Probability of x greater than or equal to 116. That's something to sort of pick up on there, okay? X is the number of people in the sample who support this party, okay? So yeah, there we are. Let x denote the number of people in the sample who support party A. So we can express x as a binomial random variable with n equal to 275 and p equals 0.45. The mean and variance there are calculated by n times p and n times p times 1 minus p. So that should give us 123.75 and 68.0625 respectively for the mean and variance. Okay, now, so the normal approximation to the binomial gives using the continuity correction. So essentially what we have to do here is use our continuity correction there. So it's essentially what we do is use this last one down here. Okay, probably if the discrete form is greater than or equal to n, when we transform it to the continuous, we turn it to greater than n minus 0.5. Now, there's a couple of things we have to remark upon there, and I didn't really do it there, but actually just to remark, we're dealing with 275 people, and that's a large sample, okay? So just to actually remark upon that, and I've been bad here by not actually spelling it out. So what we're going to do here is use the central limit theorem, okay, to justify this. Essentially what we have to say is make some sort of statement there that using the central limit theorem, because we have such a large sample, 275, it's reasonable to approximate the binomial distribution with the normal distribution. Just a quick sentence like that, okay? Just for the A1 answer there. Okay, you might even have to put in a little bit more than that, but essentially don't ignore that. Like I just did actually. I shouldn't have ignored it, but there. Have it there very prominently in your answer. Now, after that, this is very much calculating a normal probability, normal distribution probability. So probability of x greater than or equal to n, x greater than or equal to 115.5. The z-score there should work out to be very close to -1, okay? So you should get an answer there of 0.841. If you're not familiar with z-scores and complement rules and symmetry and the phi function and so on, you should really look up normal distribution questions first before coming to this stuff, okay? Just check up all that stuff first, because you're coming to this too early if you don't know how to do this question here. If this doesn't look easy or fairly straightforward or fairly understandable, just go over that first, z-scores and normal distribution. Okay, we'll leave it there.